Alright, so now back to polynomials and just a little bit of practice. We're talking practice. So, what is an equation of the following graph? There are many correct answers. Use your knowledge of polynomials to come up with one of them. Pause the video, do that, unpause when you're ready to discuss. Okay, so I came up with this polynomial, x squared times the quantity x minus 3 cubed. Now, how did I come up with that? Well, here, I noticed that it has to be an odd degree polynomial with a positive leading coefficient because the end behavior is down, left, up, right. There is a 0 at 0 that has an even multiplicity. There is a 0 at 3 that has an odd multiplicity. There are 1, 2, 3, 4 turns. So now this is where it gets a little confusing. We talked about turns have to be extrema. Well, they don't have to be. Whenever I see this sort of jog, well, jog's maybe not the right word. Anyway, when I see this sort of turning motion, where it's not just a smooth curve, there was clearly 2 turns in here. Think about it this way. If you were driving a car, how many times would you turn your steering wheel to make that sort of movement? I'd have to turn it once, then twice. So I'd turn it to the right, and then I'd turn it back to the left, as opposed to just a steady sort of curve. Anyway, so I know it has to be an odd multiplicity, and it has to be at least a multiplicity of 3. It could have been higher, but it has to be at least 3. So there are 4 turns for sure. So then that's how I wrote x squared and x minus 3 cubed. I want you to think of at least one other possible equation. And maybe you already have another one. So maybe you came up with something different originally. As long as it's correct, that's something else then. Okay, last thing, write the polynomial as a product of first degree factors, given that 1 is a 0 of multiplicity 2. So x equals 1 is a 0, and it has a multiplicity of 2. I want you to write this as a product of first degree factors, which means factor it completely down to linear binomials. Pause the video and do that. Okay, so hopefully you ended up with x minus 1 times x minus 1 times x minus 3 times x plus 2. I got there using synthetic division. So first I did synthetic division with the k value of 1, since I was told that 1 was a 0. Had my leading coefficients, divided, got 0 as a remainder, good. Now, if I know that this is a 0 again, because it has a multiplicity of 2, I can go ahead and I can just do synthetic division again with the quotient. And so what this does is it reduces it from a 4th degree polynomial down to a quadratic polynomial. Again, I did my synthetic division, got a remainder of 0. That means it's working out well. Then I ended up with x squared minus x minus 6. That factors into x minus 3 times x plus 2. That gave me my other 2 linear factors. So one thing I want to point out, the directions here, a product of first degree factors. So that's what we were trying to do. Other things that this could say would be a product of linear factors, completely factored form. I think those are kind of it, but if something else comes up and then I think about it, I'll tell you. Okay, so just because we had a short stint with complex numbers earlier today, doesn't mean you want to forget about everything you know about polynomials.